Good evening to most of you. Good morning here. My name is Brian Topping. I have a small consultancy called Coglative LLC in the U.S. Is just a small corporation that's mostly a tax construction, but this Coglative is mostly me. I have a small cluster of servers down in Denver, Colorado, close to the mountains here in the US. And I decided over the last probably year or so that I wanted to move towards Gardner. And this is kind of a documentation of my journey, how I got to, and specifically how I got to Kubevirt as my provider on Gardner, and some of the kind of just the decision process that I made to get to Gardner, and some of the tips and tricks that I found with that. So as far as let's make sure I'm on the right window. Kind of agenda, I wanted to kind of just go a little bit, just a couple slides on who we are, talk a little bit about Kubevirt, and some of the process, some of the facilities that it provides. Then really how we got into, as I mentioned, that discussion of how we got into using Kubevirt versus using something, some of the other providers that are out there, for instance, with GKE or GCP kind of thing. And then what we did to implement, how we got these onto our nodes, and how we got this cluster up and running, where we're going next. And then at the end, I want to do just kind of fill the remaining time with minor demo slash Q&A. So it'll just kind of live demo what we've got if anybody wants to see anything that's running, since we have a Gardner friendly community here. We might, I'm happy to run through my cluster and expose any of the specific configurations or setups that are there to anybody who's watching. So as I mentioned, Coglatives, and we're actually near Boulder, but if anybody, I guess a lot of folks in Europe, it's supposed to be a lot like Switzerland, I guess. So I haven't been to Switzerland, but it sounds like it's pretty cool thing. I've been doing this stuff for about a little bit. I've been not a little bit, it's quite a bit over 30 years at this point. So it started off at embedded systems. I was actually a developer on the PowerPC Mac back in early 1990s. So me and another guy did the memory manager for that machine. So I've been doing this. I've been doing a lot of programming for a long time, and DevOps is kind of a passion of mine, like a side passion for just keeping things going. I have a couple of Class C address blocks from the old days. So basically what we as the royal we, kind of, when I say that, just kind of ignore that and just say it's in your head, just think it's through me. We've got a half rack down in Denver. This is a facility where I can leave the machines running at night and not have them keeping me awake with all the noise. And I also have a half rack here in the house. The house has a fiber optic connection to, and we've got like 5 millisecond round trip time, very consistently down to that facility down in Denver. That facility is probably, I want to say, 50 kilometers away, 40, 50 kilometers away. So it's reasonably far away, and getting 5 millisecond, 24 hours a day is really good. So my first Kubernetes cluster about 3 years ago had one of the 3 master nodes actually running out of the house. So it was that consistent, with Ceph running over it and the whole 9 yards. So so I'm fortunate to have decent facilities to experiment on. But with a half a rack, you have to be very careful about what you're putting in there. You're space constrained for everything. So you don't just go in and say, oh yeah, we're going to put in a bunch of machines. You don't even have room for routers sometimes with the half rack. So really everything has been hyper converged. The routers are running on the same machines as the Kubernetes nodes, the hardware nodes. For a long time, I was running everything in 1U in that server facility down in Denver, which is basically 2 machines. So what we're working towards right now is getting a full CLOS kind of wiring configuration for 100% failover. We do have BGP running on everything. We're looking to get Sonic. I've got two software-defined routers that have Sonic on them. They haven't really been fully prepped for installation yet. So right now we're just running on one router. Sonic is a open source distribution of a I would say it's not really a distribution. It's its own distribution, but it's a Linux-based distribution for software-defined routers. I forget the standards there's a standard installer type that works for Sonic. It's a really interesting project, and they're actually looking at starting to use Kubernetes for managing their Docker containers. Sonic has Docker containers, so it's a router switch with Docker containers on it. It's a really interesting architecture if you're looking for new switches. So really what our focus was on was how many MIPS can we get per kilowatt hour of energy used. We do have a very limited, we have about 8 amps of power at 110, which isn't a whole lot. But we're within our power budget, which is great. As I mentioned, we've got 2 Class C address blocks, so we want to make sure we use those. Those are expensive, not expensive, but to us, we have them for free because we're grandfathered in. But they're resources that the entire internet would like to have back if we're not using them. So we want to make sure we're utilizing those for customers. And we've been with these guys for about 4 years, so we have a little bit of flexibility with them. As I mentioned, we've been doing Kubernetes for about 3 years now, 3.5 years, something along those lines. We learned about Gartner actually through a Kubeadmin community survey. So we're looking at Kubeadmin had sent out hey, can you take our community survey? And it was like, oh, Gartner, what's this? And, they were asking, did you install with Gartner or Metal Stack? And I was like, wow, these new things I'd never heard of. So I think there is there's probably some channels that I'm not watching well enough to know about some of these new pieces, but I did find this through really not through looking, but like, oh, I didn't know you could do that kind of thing. So once I saw it, I knew immediately that this is really where we needed to go, because it was obvious that hosting multiple disparate companies with different needs on the same cluster just simply wasn't going to work. So we started looking at Metal Stack, but we just really did not have the amount of hardware they need. They need really large amounts of hardware. That's actually how we ran into our Sonic switches. The Metal Stack needed Sonic, not Sonic, but I'm sorry, it was forgetting the name of the switches, but it's a very popular distribution, commercial distribution that's now owned by the NVIDIA group. And we bought these switches on eBay. We started getting them configured, but we just started realizing we don't even have the space to host enough hardware to deploy Metal Stack. So we started looking around, like, how can we get Gartner onto this smaller stack? I've done a bunch of hyper-converged kind of deployments before on this stack. There's no reason we couldn't do that again. And that's when we came across the Kubevirt provider for Gartner. So that really was what enabled us to actually deploy Gartner. Kubevirt wasn't just really a choice at that point. It was like, hey, this might be the only way that we can deploy Gartner with our small stack. And given that, are we making catastrophic choices here that will hurt us in the long run, or is this something that we can really live with? So that's where the process, we really started getting deep into Kubevirt and asking ourselves, is this going to be something that we can deploy with and work with? So so the question, so one question then is, what is Kubevirt, right? It's obviously core to this deployment we have here. It's actually a really rather ingenious system. From what I understand, is a lot of this was developed by the team at Red Hat. And what it is it's really a bunch of constructs around KVM and libvirt in order that you can launch HVM deploy HVM kind of VMs on it from within your Kubernetes environment. So if your nodes, your Kubernetes nodes, your bare metal nodes have the correct kernel configurations for running KVM machines, then by running Kubevirt on top of it, you're going to then end up with, on top of your Linux kernel, you got your container runtime in Kubernetes, of course. Then once Kubevirt's installed, it will launch the operator, which isn't shown here, will see the creation of a VM, which is a lot like a deployment in your typical Kubernetes kind of pod environment. It's a VM is a container for VMI, VM instances is what the VMI stands for. And these VMI instances then the operator will then create at the kind of lower level of the stack, this launcher pod, which contains your libvirt environment. So when we think about running KVM on normal machines on a regular non-Kubernetes environment, we use the versh command and we already have KVM installed. And so when we say, we tell through versh, maybe we give it a, which is virtual shell in KVM. We might give it an XML descriptor of the VM that we want launched, and it goes ahead and sets up the kernel environment so that guy's up and running. When you do this in Kubevirt, what happens is this launcher container gets brought up. Oops. The launcher container gets instantiated, and then your versh environment is actually running inside that container. So as I'll show that a little bit later in the demo of how that works. But basically everything's nicely contained. It's you don't have problems with ephemeral containers. In this case, heavyweight VMs running on specific hardware, so your nodes remain nice and clean. There's a lot of really cool advantages to this, but it's still, mind you, this is still using HVM kind of virtualization. It's what we're trying to get away from in Kubernetes, and suddenly we're going back into it in order to run our Gardener. So it's a little bit of a context shift for a lot of people in thinking about how to use Kubevirt, and that's part of where I wanted to provide some exposure to the Kubevirt provider here today. So. As far as a need to know on this, I kind of covered a little bit of this already in talking about it with the diagram. The versh command doesn't, if you go down to the node level and type versh list, for instance, you won't see anything. It's not running there. It's in the container, so you have to kube control exec into that container, the launcher container, in order to see what's going on there. So it is running, though. The VM actually is running on the node's kernel, and what it wraps it with are the Kubernetes constructs. So your KVM XML gets translated to YAML. Your logs are going to be in the right locations. Your also your networking and things along these lines is going to be mapped in properly. So there's a along with Kubevirt, so that gets you the idea of getting a how should I say, a VM started, right? If you've got a VM base image, you're going to be able to go in there and say, okay, I've got this base image running, and Kubevirt can launch it up. But how do you get the base image, right? So when you're in an ephemeral environment where you're trying to see these virtual machines get launched in a Kubernetes kind of style, where you just declaratively say, I want this virtual machine up and running, Kubevirt by itself is not enough to do that, nor is KVM. So the Kubevirt team brought in, created this concept of a container data importer. And so the CDI it's deployed separately, but you almost would never do a Kubevirt deployment without CDI. The Kubevirt provider in Gardener has also assumed that this is going to be in place. And really what it's doing is pushing down, just like Gardner and Kubevirt themselves have this kind of layered concept of creating API objects that then trigger other parts of a reconciliation process. The CDI is doing the same thing with what they call data volumes. Okay, so when a virtual machine instance is coming along and saying, hey, I expect a data volume to be set up for me, what often happens is the data volume gets created as a API object, and then that gets reconciled by the CDI. So the CDI goes out and actually downloads the QCOW image, turns it into a block format file on your systems, and then once that's ready, then reports that, it sets the status on the data volume that it's ready, and that reconciliation at the higher levels, the dependency on that data volume then can continue moving forward in order to launch the virtual machine. So there is a fair bit of complexity just even in Kubevirt itself. It's not overwhelming by any stretch of the imagination, but there are some pieces with this, and the things that are interesting on it is for instance, the networking. I mean, you can get in there and find that, oh, well, I've got this virtual machine running. I don't have any way to get to it, right? It's just this kind of orphaned machine, and that's going to be very common in your first Kubevirt deployments, that you can't get to it. So, but it is very flexible networking. It's just a straight CNI kind of binding. So you can do things like Multis and actually have that VM on the network of the host, or of the node. I want to say the bare metal node. So you can actually get a Kubevirt virtual machine binding on an IP address of the node. It's really not that hard to do, but it's really overwhelming the first time you do it. So VM scheduling, one of the advantages of all this kind of thing is the VM scheduling is very similar to pod scheduling. If you've got a 10 node cluster, you can go out and have your VM scheduled wherever the resources exist. And Kubevirt knows how to, when it's scheduling virtual machines and locations, it knows how to interact with Kubernetes to find out where those resources are available. So what this really starts to do is, they talk about on the web page, and it really is true, that it gives you the Kubernetes kind of flexibility for old school style virtual machines, and it really does work well. So the thing that is really, I think, helpful to know with Kubevirt is that it especially in its application in Gardner, is they both work together through Kubernetes topology labels. So your node topology is really essential to make sure you get that set up early on in your deployment, and so that when Gardner starts to come around and instruct Kubevirt where to create these nodes, that they can work together by understanding the topology labels of your bare metal nodes. And so I haven't done this. I should also explain, I haven't done this in anything but bare metal. So when you hear me talking about how Kubevirt deploys and things along those lines, I don't even know if you can run Kubevirt in the cloud, in public clouds. So that's something I haven't really explored, but I would assume maybe that you'd be able to take up a GCP node and have it go through and do the right thing for that. So I'm not going to really touch on that. So let's see. So then there's also combinations of this. I wanted to touch on this, that if you, like, for instance, if a virtual machine needs a high-speed disk and you're using something like Ceph for distributed storage, Kubevirt's gonna, and really not Kubevirt, but I should say the CDI, when it sets up your block device, is just going to say, oh, okay, well, my storage class that I'm configured to use, let's say my default storage class is on Ceph, then it's going to give you a network volume for your virtual machine, right? Which may not be the most efficient thing that you you might need something with better IOPS for your local virtual machine. So you can do things like Topo LVM, which is a LVM provider that understands your Kubernetes topology and works with the Kubernetes scheduler. And so that it's also a scheduler extension. So when jobs are getting scheduled, it can schedule them on the machine that has the local storage. So there's combinations like that also work with Kubevirt. And so you can go through and do some pretty unique things that you didn't think you'd be able to do, and things like Topo LVM can enable that. They've been making a ton of progress on Topo LVM. If you haven't checked out if you've tried it before but you haven't checked out their latest release, it's really quite comprehensive, very easy to install. A lot of the older problems that they used to have that were external kind of userland applications that needed to be installed and running are taken care of at this point. So let's get into, I want to touch on some of the reasons, I touched on a few of the why we chose the Kubevirt provider, but I wanted to go through kind of our analytics of how we thought through this problem. And so that, maybe it can give a head start to others who might be considering the Kubevirt provider. I touched on this one already, but it's one of the things we know is, as a small enterprise and having been doing this for a while, I know that my development can get interrupted at any time. I can get a contract coming in from a company that I just really don't want to pass up. It's an exciting opportunity or something like that. And when that development is interrupted, if I've got a huge server farm sitting in Denver burning away every month, then I could really learn to regret having that large deployment. So literally we're at a point right now, we're spending about $300 a month for our half rack. So when you can get things into a mode where you've got a very inexpensive half rack, then you can, and you can leave that running when you've got some other contracts coming in. It really looks attractive to go with a smaller rack. Now the question is, how can you get that compute power out of that footprint? And one of the things that when you do the math on this, is that your best power, your best MIPS is going to come out of maximum large core processors. So we're running 20 core V3 Intel V3 processors on this stack. It's something I didn't really stick in here. All our hardware is used. It's all from eBay. I don't think I've bought anything new except for maybe a cheap switch to, until we get the what do I call it? The sonic switches deployed. And even those sonic switches are used. So I bought those from a guy up the road that happened to be selling them. And we ended up going out for dinner and doing a bunch of other stuff too. So really I guess the key of this is, how do you get as much power out of that? And one of the options here is this kind of machine you can see lightly in the background. That's a 12 motherboards that are vertically oriented as blades in that machine. That's a 3U machine. Those nodes only individually support up to 16 gigs of RAM each node. So and then direct attached SCSI for your storage. Or not SCSI, I'm sorry. SATA is what I meant to put there. So it's not direct attached SCSI, but SATA. And so you don't have any kind of diversity in your storage options. For instance, you're not going to put a Ceph cluster across 12 nodes that have small amounts of disk, and especially with 16 gigs of RAM. It's really not going to give you a whole lot of power out of a system like this. But in the US, a used machine like this is about $3,000. So it's a really expensive option to go with. And also with networking, these are only gigabit network ports on here. So you can't get into the 10 gig. And if you're not in 10 gig, you're also not getting into SRIOV. So you're not getting network virtualization either. And you don't get network virtualization until you're at least up in the 10 gig space. So after looking at these, we realized that there was some advantage in that, like Spectre meltdown mitigation is a lot easier because now you've got these motherboard silos, but you don't have much flexibility at all as far as growing this thing out. So that was a big pointer towards Kubevirt. Even though the Kubevirt provider is expensive from a performance perspective because we need to turn on all the Spectre and Meltdown mitigations, the fact that we could go in with 40 cores per motherboard instead of, on these nodes, I think they're probably at 4 to 8 maximum. It was night and day performance kind of things for the amount of space we were using. This is, and that's still an issue, right? This is a 3U machine. If you've only got 20U to work with in your data center, then 3U's is a big cut out of that. So so as I mentioned, kind of VTX and speculative execution bugs on the processors. This is especially important if you're buying used hardware. You really need to understand the CPUs you're putting in to these nodes and make sure that you've got everything configured for, for safety. So, quick question, Pavel. Do we have is there another presenter that's coming on at 7:30?
Nope. I think you
Okay.
can use the full slot.
Okay.
I mean, we booked for 30 minutes, but if someone has to jump for another call, we're going to share the recording, like we said. So feel free to continue. And if someone needs to jump out, you can watch the recording. Okay,
great. So I don't have a ton more slides, and then we'll go into the demo. So, but so we do have HVM, the style of virtualization, because we are running full virtualization in these Kubevirt containers for our I want to say the Gardner nodes, if you will. So these because we don't have all that hardware, right? We're going through and saying our customers are running in virtual machines that are acting as nodes for the Gardner chutes, right? So basically what we're expecting is we're just not going to get full performance out of these nodes because of our turning off of a lot of the optimizations that used to exist before Spectre and Meltdown. Kernel 5.10 does introduce something called static call. I haven't really dealt too much with how to optimize for that. Network complexity is another issue on this, again, this small tight cluster. When you've got a lot of virtualization happening on each node, you've got a lot less wires happening to each node. So again, we're using 10 gig connections between these nodes. There's actually 7 of them total, just for context. And so we are able to get into the SRIOV to reduce network stack overhead and get faster traffic, more efficient traffic. Everything that we're doing within these, though, it's just almost essential. You almost have to plan that you're going to be using BGP, because when you've got a customer announcing an address on one of their servers, where is that server? You don't know. It's not going to be on a specific machine. Static routing is really not going to work for you, especially when you're talking about public addresses, which have they're an expensive resource, right? You're not just going to throw a bunch of addresses at each machine, and you're definitely not going to expect they're going to stick with a specific machine. So I have a lot of experience with Cilium, so that was really my go-to originally. Putting it on the Gardner Slack channel, folks were like, "Wow, so you want to do this on bare metal? You want to do it with Cilium?" And well, good luck with that. We'll be around to answer questions, and it's going to be interesting to watch your progress on this. And it literally took me quite a few months. So how you approach this will definitely should temper your expectations on how long it will take you to get this deployed. Everybody, as I'll keep reiterating, has been extremely helpful. The Gardner team, there's just not enough funds in the world. We're really blessed to have SAP supporting this project, and being able to give back anything we can, like this presentation, or if I can get on Gardner Slack channel, just ping me by name. You tag me for questions that have anything to do with any of these, and I'm happy to throw in as well. So one of the things that Cilium doesn't have, though, because it's also in its own silo of and optimizations that they're looking for. Cilium network policy, you can't turn on Gartner network policy with Cilium running, or I guess you could look at that vice versa, that Cilium needs network policies to be globally turned off for Gartner to work. So it's a very, if you're thinking to go directly to production with a Kubevirt kind of environment like this, you may want to have tap the brakes a little bit about using Cilium if network policies are a make or break kind of thing. I don't feel that I can release this current setup, for instance, into commercial use by public customers until those issues in Cilium are worked out. And I just haven't had time to go in there and make those try to contribute to those changes. So I do have a note there that because we have 2 Class C blocks, there were some code changes also required to the Kubevirt cloud provider in order to get those propagated through, and I can try and demonstrate some of that in the end of the demo. So this is very much a work in progress as far as the network setup. Storage was a lot easier because we have, as I mentioned, we have 7 hard nodes, 7 bare metal nodes that this is all running on. Most of the nodes have 6 SATA ports on them, and then the densest node that we have has 4 separate motherboards on it. So there's a total of 24 2.5-inch drive caddies on that machine, just lining the front of it. And what we've got in that kind of configuration, and we also have 3 different nodes with basically leading to 3 different power supply sets. So that was another kind of topology consideration in laying this out. We wanted to make sure if somebody tripped over a power cord that we weren't going to lose kind of the cluster quorum for not just for Kubernetes, but also for Ceph, right? So your storage on this is storage layout for a small cluster becomes a lot more important because you don't have as much kind of failover in your cluster to depend on. So, but what we've got now, again, through that kind of topology labeling, we've got a situation where the system can mostly figure itself out where it needs to place things. Ceph is very good at this kind of thing. So they've been doing it for a long time. But Gartner figures it out as well. Gartner depends on that topology, and Kubevirt is already configured to use topology, or at least be able to be programmed for topology within the VM definitions of where it wants things placed. So everything worked really well with that. The one thing that we started to, kind of, and this is kind of an aside that's really not particularly focused on Gartner, but how to deal with client managed encryption. So we want, basically, as far as I'm concerned, clients should be owners of their own keys. They should be custodians of their own keys for volume encryption. But if we were to go through and then encrypt the volumes on the machines that Ceph was running on, we would end up with double encryption. So we've just kind of converged on the idea that if you want volume encryption, then you've got to do it yourself. And if you don't, then it's really a physical security problem that that we're basing on our ISP and their policies and our locked cages and things along those lines. So we do want to get through a security audit to make sure somebody else has put eyes on this configuration. We are using at the subcluster level, we're using what they call Ceph's external volume or external cluster support. So essentially what we're doing is the client clusters are connecting as an external cluster to Ceph, and then we've got the RBAC in Ceph set up, and so that the clients can only access certain parts of that. That's a blank slide. I'm not sure what happened there. Oh, that's why. So once we got through it, you can kind of start to see where our how should I say, like the boundaries of what we had to think within. and how we came to, again, kept centering back on Kubevirt and a little bit of HVM overhead in exchange for having this small and tight cluster that we could get up and running and get our experience with Gardener up and going. So we thought, hey, this is all, we've got a good handle on this. Now what comes next? Gardener on bare metal is hard. I just want to put that out there. It's not because Gardener is hard. Gardener is a very comprehensive system that in its own right deserves a lot of study before people depend on it. It's a little bit like doing backups. You don't just want to go into production with a new backup strategy. You want to have tested this backup strategy. You want to know that you can recover from inevitable hiccups in a graceful manner that's within your SLAs. And Gardener on bare metal is really something that I don't think it's done a whole lot. So you've got stuff like Metal Stack, but Metal Stack has optimized for additional hardware in order to overcome the how should I say, to fit better into the Gardener model, if you will, right? The facilities that Gardener already provides, I would project are easier to do when you've got one full hardware node per customer node, right? And so there's no Kubevirt mapping. You're just throwing more hardware at it instead of trying to virtualize these the chutes, the machines that support a chute is what I guess the language I need to be using here. So the Gardener team though is amazing. So if you've got some patience and you're able to fit into their schedule, getting on Slack and you're going to find that there's a lot of people out there that can answer questions. And I think they like the questions. My experience with it has been like, wow, you've got some interesting questions here. Let's see what we can do. So the community is something that I think will grow over time. And part of the reason I wanted to do this presentation is to raise awareness in the Kubevirt Provider. I don't know that there's anybody who's actually in full production with the Kubevirt Provider yet. So I'd love to help somebody else start using the Kubevirt Provider and start creating a little mini community around getting some of the quirks worked out into very predictable kinds of behaviors on deployment. So so one of the things that will come up in your, if you're just starting with Gardener, is this kind of how to get it deployed, whether you want to use Garden Setup, Helm, or Landscaper. So again, this is there's a whole set of different pieces that if you don't know Gardener, you're not going to be able to make an easy decision between these three forms of deployment. But there are some kind of roadblocks here that you're going to need to know about, and that is one of them is that Garden Setup really only works in existing public cloud deployments. So if you're looking to homogenize your disparate kind of public cloud deployments, like let's say you're using both Amazon and Google and even Azure as a combination in order that you can move workloads between them as their prices change, then you can easily go in with Garden Setup and start working with this kind of homogenized setup over these disparate providers very quickly. If you're trying to go in on bare metal, it's a very different story because there's just not enough bare metal users out there. And that's where, kind of helping the community grow around bare metal is something that's going to benefit all of us. So Landscaper doesn't really exist yet. It's a awesome idea. And if you read about it, you will be like, oh my God, I want this, right? But it's just not, when we started looking at this and I started asking about it, I think it was about 6 months ago when I started on my Gardener journey. It wasn't ready back then, and I haven't looked at it. I do intend on changing over to it though. I think it will be ready, and when it is, it's going to make a big difference on how things are deployed. So, so basically, Daniel Ford had started up a thread that I have linked here. I have it actually on another slide and further down, and I'll go through some of the key parts of that, when we get to that slide. So. So basically, on this slide is, is kind of kind of some of the tricks that I had done with this. You really need to plan a few months on if you're going to go on directly to bare metal for your first deployment. I would not, if you have the resources and the funding, I would start with garden setup. Build yourself a garden on public cloud resources and really get to know what's going on there. If you don't understand the basic paradigms of Gardener, you're not going to recognize when you're on bare metal how this stuff is broken. And so I was looking at problems in my cluster. I didn't even recognize them as problems because I hadn't run Gardener before. So I can't tell you that it's going to be faster to get bare metal up and running by first running for a month or two with garden setup. But I can tell you it's going to be a lot less like kind of broken light bulb situations when you're sitting there staring at something and not understanding where to go with it. And the way I got through them was actually loading everything into IntelliJ and literally opening up the source. I'm a programmer, so opening up the Go projects and checking out why these things, the expectations that they were setting at these different controller levels to say, oh, that's what I'm missing. That is what got me through this. It wasn't that I, except there's a certain point in any open source project when you're leaning too hard on developers, they just can't help you anymore. You need to save your get out of jail free cards for when you really need them, because you will need them. So focus, if you're going to do it this way, on opening the source, getting in there and understanding what's going on in these operators and controllers, and you're going to be a lot further down the road with your deployment. So this is the thread that I was talking about. I actually bookmarked this on or pinned it on the Gardener channel, so you can find it very easily. It actually got unpinned and I repinned it. This thread is like became my Bible, right? It really is something that you can live by for getting a basic bare metal cluster up and running. So I won't go through these particularly closely, but one of the key bits of this is there's really only about 4 Helm charts in this. It looks like a pretty, if it just kind of first glance, it might look a little bit overly complicated. There's really only about 4 charts in here. You want to make sure that there are 0 errors at every chart deployment. That was a mistake I originally made. I wasn't paying super close attention to the logs, and you want to make sure that they are absolutely clean. If there's anything wrong in one of them, don't move on. It doesn't matter how many days it takes you to get those errors cleaned out. So that once you've stepped through these, and the other thing to note on your deployments is that the controller registrations will include a lot of the pieces that you think you're seeing in some of the charts. So you don't need to go through and say, oh, I see in this chart that this should be deployed, I better deploy this chart. Avoid that temptation. The Gardener is going to deploy a lot of those charts for you as the prerequisite charts get deployed. So you can really stick to the 4 charts that are listed in this thread, plus whatever, for instance, your networking controller registration and things along those lines. So I'll show you my controller registrations in a minute, and you'll see, wow, this really isn't that bad to get this going. But getting that primer is really helpful. So as I mentioned, we went through and I probably deployed the cluster. I probably destroyed and built the cluster probably 30 times. I've never done it quite that way. I remember installing Oracle when I was a kid and having to, always said, oh, the 3rd time's a charm, and it would take a couple of days. Gardener is a masterpiece of code with the interaction between the controllers and the reconciliation loops. And there's a lot going on there. So, instead of trying to go through and say, oh, I'm going to fix what I broke, I went through and said, I'm going to wipe it clean and make sure that my configuration, by the time I get to the end of this, the configuration is pristine. I did not want any gremlins lurking in the background of my configuration. So that was the reason I made the choice to keep reconstructing the cluster instead of fixing what I had. One of the things that I found, kind of midway in there is, there's always this temptation to go and like get your multi-mastering going with Kubevirt or whatever your bare metal installer is. I would not waste time with that. I would really focus on getting a single node single master cluster going with no worker nodes. Do everything on a large node and get Gardener up and running. If you're, and again, this is with Kubevirt, right? This is only going to work with Kubevirt. But just gen on a single node and plan on rewiping it, doing it over and over again. Make sure that your node is very, very scrupulously set up. Make sure that your DNS resolution is all set up and that you can do both full host name and individual node networking. It's a little bit different. I also switched from CentOS to not Debian, but Ubuntu in the middle of this deployment as well, because I wanted to be closer to what the Gardener team was using and avoid problems that were coming up that way. Going with kernel 5.10 helped a lot with Cilium. It didn't, your kernel version isn't really going to make a big deal with some things, but with Cilium, because it's doing all the low-level kind of kernel hacking that they do for BPF, you want to have a later kernel. And so getting that stuff set up early on is going to save you quite a bit of problems down the road. Also make sure you do your virt host validate EMU, so you can go through and make sure that you're just doing your checklist, that you've got all the pieces that you want to see eventually once you start using Kubevirt. So I mentioned this before, make sure you keep checking your logs and make sure that there aren't any errors. Don't deploy the next chart until you get your existing errors done. As soon as you get Kubernetes installed, which is to say that it's before you start loading Gardener, make sure you set up your topology at that point. The minute that you can start adding topology labels to your hardware, your bare metal nodes, you want to start doing that. So I found, just because I was new to Gardener, that colorizing my terminal windows helped a lot. I made the core, what I want to say, the bare metal nodes, I made those windows with a red background. I had too many times did a Kubeadmin reset on on the root node and just wiped everything out. So that would add a day or two to my development process immediately, and it was just like, I can't believe I did that again. So that's just a learning, and getting used to having that many clusters running. You may already have that, and I didn't have that experience. So crew and plugins like CTX and config are going to be your friends on getting these multi clusters set up. And I kept a very lengthy journal, handwritten journal of my installs and what I did. And so because sometimes I don't know if it's just a personal problem with memory, but there were days where I was like, what did I do like a week ago? I know I solved this problem. Being able to scroll back to those journals and search that stuff saved me far more time than I lost to actually writing the stuff. So the last thing that I'd probably throw in there is configuration management tools like Terraform would probably be very helpful, but I avoided them, just simply thinking that Landscaper would come along and knock that stuff out. So I don't know if it was a good idea or not at this point. I'm still looking forward to Landscaper. Having seen what I've seen in it, I think it's going to be amazing. And I really just don't want to cloud my brain with Terraform knowledge if I think I can get away with not doing that, just because I have a lot of other programming languages I try and remember as well. So that,
Brian?
I think, yeah.
Just from the perspective of the time, because we're a bit over, and I'm sure there are a few people that probably want to ask questions, I would recommend we try to kind of go towards the interactive part. I mean, feel free to maybe say a few more words, but I would recommend we also have a few minutes for Q&A.
Okay, and so I'll put the slides up. I'll make sure that Pavel's got the slides, and so that we can keep those linked to this, since I'm going to just kind of blow through these. The last thing that is I kind of mentioned already, is really trying to, as far as the things we'd like to see, I think it really comes down to community. We really need to help grow the community, and so that we start getting ideas bouncing off of each other. But more importantly, that we've got contributors that can contribute some of these things. And so understanding how to deploy with Go and how to push into the repositories to get these containers up and running is a lot of people know how to do that, and that's great. We need to bring those people together, and so we can start to implement some of these features. So let me stop real quick before I get into demo and start with the Q&A up front, and then if there's no questions for that, then.
Yeah, so thanks, Brian. First, I think it was a very insightful session. So I enabled unmuting for everyone, and depending on how it goes, I think we are a bit over time. But if we have a lot of questions, I would propose we focus on them. And if you have the time, I don't know, in a few weeks or later, I would suggest we do a separate session on the more detailed demo if you want to maybe share more in, I don't know, 20-30 minutes just to walk us through your demo, so you don't have to rush now, but it is completely up to you. I think it's going to be very interesting for all of us, so we can also do that as a separate dedicated session. Up to you.
Yeah, I'm flexible, so it's anything that any place I can help, and I'm on Slack like pretty much anytime I'm awake. So if there's something I can help with, just tag me. I might not, depending on time zone changes, because I'm in Midwest US time zones. I think it's +5 GMT. So I may or may not be awake, but I will get back to you. So, don't hesitate to ask there as well.
Yeah. Super, thanks. So I think it's going to be very interesting for all of us. And now I believe everyone should be able to unmute. So if there are questions, I'll be very happy to start with that now.
Yeah, hi, Brian, this is Vasu. Thank you for your describing your journey. This is really exciting. And I think you're really the first who's trying out the Kubevirt on bare metal indeed. Yeah.
Cool.
I'd like to first, technically I have some questions, but first of all, where are you using it? For what are you using it? So you're producing Kubernetes cluster in the virtualization, but what is the use case? Is that for your development things you do for companies, or what's the workload like?
Yeah, so it's hard to describe my brokenness, if you will, with how I develop companies. I tend to go big before going small, and that hasn't really paid off in a kind of, how should I say, personal way. But at the same time, I'm not too worried about that, and I try to focus on what are the things that we're actually going to need to do the job right. So I try to build from the bottom up instead of the top down, with the idea first of what we're going to deploy. I do have several kind of things like social media system I wrote a few years ago that I think, in Scala and Akka, that I think would be deployed very well in a cluster like this. But it really came down to just saying like, hey, I don't want to convert my Kubernetes cluster at a later date to being able to host multiple users. So that's where it kind of grew from. It was more of a, I don't want to have to do this later with my limited set of hardware, than it was something that was like, yeah, I've got a need for this. I've got customers waiting. It was just a very ad hoc kind of like, let's do this now. Let's just get it done.
Okay. All right. And the one technical question is, so you're using Ceph, and you're putting into the virtualized environments, you're putting the Ceph CSI into place. Yeah. But if you're really multi-tenant, that's not quite as safe as, because all of the virtualized tenants can reach the same Ceph environment. Yeah. And
right.
So from a security audit perspective, and that was one of the things which was open around the Kubevirt extension provider that we built. We're waiting for kind of a bridge to put a CSI into the virtual layer that actually talks to the host layer where Ceph will be installed, right?
Yeah, so basically what, because I'm not, I know that there's some huge gaping security holes in here. I'm not letting people I don't know build clusters on this, right?
Okay.
So what I've
friends and family. Okay.
Yeah. So.
Okay.
I mean, we are here on the Gardener on Metal project. I guess you already contacted us someone, and we looked in the Kubevirt provider, and this is a real issue for us to use this. because we want to join into this virtualization provider the disks from the virtualization environment. And the problem of this is that Kubevirt doesn't allow us this. So therefore, we wrote our own virtualization provider now, because Kubevirt has all the hard disks in an immutable state. Yeah? Whenever you provided hard disk to a Kubevirt, you have to provide it over your manifest, and then it's immutable.
Not sure if I understood that, but it's
yeah. When you go to Kubevirt and you define a machine, then all the machines that or all the disks that you mount in there, you have to define in a pod definition, and that makes it immutable because a pod is immutable on the disks
right,
you apply, and so therefore the interesting part would be. Or the interesting part for us would be to have a more flexible provider, and that's where Kubevirt was just a dead end for us.
I see.
Meanwhile, there is a Kubevirt CSI driver written by the Kubevirt community, mainly the folks at OpenShift. But this happened after I personally was really active on this Kubevirt extension, so it's not really integrated into the Kubevirt extension. And we haven't really talked about it much since then. Just mentioning it because that could be some way to go forward, perhaps, on this topic.
Yeah, but Stoyan, you know, from our side, we looked at it, and it is the thing which extends this over this. The disks are mounted in pods, and then the pods are exposing the subdirectories, which is, as we expected in the beginning, a performance problem.
Sure, yes, I'm not saying this is without any problems. Just mentioning it as something that exists now, but it's not.
Yeah, but cool, you sent the link. Yeah.
Thank you. I hadn't heard of this either.
Yeah, it's pretty new. We requested this, but this had problems. The other thing you said you're not using, you didn't want it to go with those Cumulus switches, which I absolutely understand. We move our switches also to Sonic. But on the bare metal side, if you're not using Sonic, or do you use Sonic? I didn't got the full story on your side.
Yeah, we did. The switches that we bought don't actually have the support for Sonic quite yet. So there was a crasher that every time you'd reconfigure it, they would just reboot. So I haven't had time to address that. But the switches are sitting there waiting for some love. So I just haven't had time to do it.
And just from our side, I mean, we should maybe we should talk on that offline. But we figured out that what we do with the switches, so they have some BGP provider in there, and the BGP providers are not used by the community. We talked even to the community on them and asked, hey, are we too stupid to run them? And they said, no, you aren't. We are just using them different. And then you figured out, okay, cool.
Yeah, I'm really interested in their actual Kubernetes on Sonic efforts. It's you know, they're kind of nowhere with it right now. I think they're taking a very unscientific approach to how they're doing this. But that's not a criticism. That's just recognizing that I might have done it slightly differently, and I don't want to be the gadfly who's just constantly saying, "Oh, you should do it this way," kind of thing.
Yeah,
so kind of
exactly. The same here. We are in the same community meetings. I think I saw you there.
Oh, that's right. Yeah, we talked on email a couple times, haven't we?
Yeah,
I forgot.
Yeah.
And thanks for attending.
And those guys really talk more about optimizing the Docker world than using Kubernetes. That's interesting. Yeah. And I always don't want to be the asshole there.
Right. I'm glad. Thank you for saying it. I'm coming from America. I swear like a sailor. I didn't want to be the first guy to say something. So. Well, great. So please do. I think we are over time, and I've got a stand up that's already started that I'm supposed to be leading. So I better jump off the phone. But I am, like I said, please don't hesitate to reach out to me if there's anything I can do. You know, the Gardner team has been amazing, and I do want to give back as much as I possibly can, which I will never repay that debt, but I can always work at it to try and work harder to repay that. So I'll be online, and Pavel, yeah, I definitely think we could go through do some more demo on this, you know, with actual screen sharing of what's going on, and have it for more open Q&A of like, how did you do this, or how did you do that? Can you show me something here? Can you show me something there? So.
Cool. Thanks, Brian. I think it's very good if we do that as a separate session. I guess also the colleagues have to jump. I heard few already reminders of Outlook reminders. So I'm sure everyone's already on the way to next one. And we will probably have to chat about scheduling a second session that you really do the interactive part. And I really enjoyed this one today. So thanks again for taking the time, especially such early slot for you. I think it was 7 or 8 in the morning. So we really appreciate the time here in Europe. And look forward to the second session.